All right, guys, I know you're dying to figure out how this last problem ends, so here we are. Again, this is the end of the 10.1 problems. I just didn't finish it in the other video. Okay, so we've got to find the height here. We don't know the height. Height. I don't know it, but I do have a little triangle, so we're going to do the little triangle trick that we did on the last problem, so I'm going to put it over here. This time it's not a 45, 45, 90 degree triangle, it's a 30, 60, 90. Again, my angles are the same, 60 degrees, so this one has to be 30, and I know that my hypotenuse is 24 because I know all the sides are 24, so I know this guy's 24. How do I go from the hypotenuse side to my, can only go to our 30 degree side. How do we get there? Divide by 2. Awesome. So if I do 24 divided by 2, that gives me 12. All right, that's cool, but that's this side right here. That is not helpful. That's not my h. So what we need to do, or I guess what do we need to do in order to now go from the 30 degree to the 60 degree, the short side, the short leg to the long leg? Multiply by root 3. Awesome. 12 root 3. Earlier I said I only want radicals. Keep it the same. This is your h now. So we're going to use this to find my area. So we know area of a parallelogram is base times height. So if my base is 24 and my height is 12 root 3, we're just going to multiply those two together. 24 times 12 is 288. Area equals 288 root 3. And we always have our units. This time it's inches, not centimeters. Inches squared. Okay, awesome. All right, sorry I didn't get that in the last video. Now we're going to the back side of your notes. This is 10.2, area of trapezoids, rhombi, and kites. So, area of trapezoids. Trapezoids is a quadrilateral, four-sided figure. Four sides with exactly one pair of parallel sides called bases. So these have to be the sides that are parallel are the bases, B1 and B2. Let me move this guy so you can see B1. B1 is the shorter one, B2 is the longer one. Actually, it doesn't matter. You'll see in a second. The height of a trapezoid is the perpendicular distance between the bases. This is the same height that we've been doing in everything. It's my altitude, it's my height, whatever you want to call it. The area of a trapezoid is the product, we're going to multiply, of 1/2 of the height and the sum of the bases. Sum means plus. So to break that all down, the area of a trapezoid is equal to 1/2 height times base 1 plus base 2. So again, it doesn't matter what your bases are, it just matters that you have two of them, you add them together, multiply that by 1/2 and by height, and that's your area. The only difference from this being a triangle is this little part here, is we have two bases, so we're going to sum. This is your only difference from area of a triangle. Okay. Remember that height must be perpendicular to the bases. Must be perpendicular to the bases. It cannot be one of the slanty sides, it has to be perpendicular. Okay. Area of rhombi and kites. A rhombus is a parallelogram with all four sides congruent. All four sides are congruent. A kite is a quadrilateral with exactly two pairs of consecutive sides. Do you guys remember what consecutive means? That's right, next to each other. Remember that the diagonals of kites and rhombi are perpendicular to each other. We're allowed to use this rule here for both of them because that's true for both of them. Diagonals are perpendicular. So the area of a rhombus or kite, if we label the entire length of the diagonals D1 and D2, then the area is just 1/2 D1 times D2. It has to be the entire length. D1 goes from corner to corner, D2 goes from corner to corner. Same thing here. D1 goes corner to corner, D2 goes corner to corner. So we just do 1/2 diagonal 1 times diagonal 2, call it a day. the side note says you can also find the area of one of the right triangles and multiply it by 4. There's a lot of creative things that you can do here. Just this is kind of a shortcut, especially if I give you diagonals. For a kite, you could use areas of a triangle to find the area of a kite again, too. There's 3 different pairs of congruent triangles. So you can find kind of any different piece here and see how you can piece it together to solve. Okay, let's do some problems. We've got 3 examples on this page. Find the area of trapezoid EFG. So this is given, the first 2 examples are given coordinate planes like you see here, and then the last one's just an actual drawing. So it says find the area of the trapezoid, so we got to figure out what all the side lengths are. We're lucky though because a couple of ours are just vertical lengths, so we can just jump. So actually the 2 bases, which are, yes, EH and FG, those are my 2 bases right here and right here. I can just count those. 1, 2, 3, 4. 4. I can count the bottom one. 1, 2, 3, 4, 5, 6. Makes sense. That one does look longer than the other one. 6. Okay. If I want to find area, we know area of a trapezoid is 1/2 height base 1 plus base 2. If you didn't remember that, look further up on your page. I have both my bases, so we're doing okay there, but I don't have my height. However, I'm lucky again that I'm just going to count. Now, if they weren't on a straight line, we would have to do distance formula, but I'm not going to make it harder than it has to be. So 1, 2, 3, 4. My height is 4 as well. So I'm going to plug and chug. A equals 1/2 4 times 4 plus 6. Order of operations, I'm going to add what's on the inside first. Area equals 1/2 times 4 times 10. You can think of these as all over 1. And I can just take out a 2 once. So if I do 2 and 4 both have a common factor of 2, I only get to do that once. I don't get to touch 10. So now I've got 2 times 10. Area equals 20. And I just am going to call it units. I'm going to say 20 units squared. Again, if we need distance formula, we're going to use it. Do I need it? No. So no distance formula today doesn't mean that we won't use it another time. That's why the ominous ... dots are there. All right, questions? Let me know. If not, move to the next one. Find the area of kite ABCD. Okay, so find the area of the kite. Again, I said you could find similar triangles, blah, 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 multiply them together, solve for that. The easiest thing here, though, is using our diagonals. We just learned that the area formula for a kite is 1/2 diagonal 1 times diagonal 2. 1/2 times diagonal 1 times diagonal 2. If I find the diagonal lengths, I'm golden. So let's do diagonals. Remember, diagonals are across the shape, so it's going to be A to C counts as a diagonal. 1, 2, 3, 4, 5, 6. 6 units. And then B to D is also a diagonal. 1, 2, 3, 4. 4 units. Not too bad, right? A equals 1/2 times 4 times 6. We can multiply 3 numbers together. Again, put them over 1 if that helps. I'm going to factor out a 2. If you want to throw it all in your calculator, fine, but if you get a decimal and I ask for a simplified answer, don't give me a decimal. 2 times 6 is going to be 12, so again, I don't have any other units, so I'm just going to say 12 units squared. All right, cool. One more. This one says find the area of the rhombus. So it gave me a rhombus. All 4 sides are the same. I have no idea what the outside sides are. I could find them if I wanted to, but I do remember we were just told area equals 1/2 D1 times D2. That works for kites like the last problem and rhombuses like this problem. So if I can figure out what the entire diagonal is, then I'm going to use that. So the diagonal from here to here, I know that 7 goes from like the corner to the middle, and then 7 again goes from the middle to the other corner. So that means that that whole distance is 14. Likewise, while I know that the distance from the middle to this corner is 8, I can infer that, what is happening? I can infer that the distance from this corner to the middle is also 8, which makes this entire distance 16. So I've got 14 and 16. Those are my two diagonals. So I'm just going to do area equals 1/2 14 times 16. Again, I can multiply three numbers. Cancel out the 2. I'm left with a 7. 7 times 16 is 112. This time I was given a unit, so I have to use the m, meters squared. All right, questions, comments, concerns, let me know. Try these examples again if you have any questions. Remember, the formulas are on your paper. There are 4, I think. Look at them, study them, use them. Okay? If you need help, let me know. Bye.